then people like Geico and Hey.com, and they were spending more. They were spending around $200,000 to $250,000 or more. And at that point, the cloud became a limiting factor where people started noticing, hey, I'm actually going slower because I'm in the cloud. This is taking me longer to do things because of the complexity of hundreds of AWS accounts and VPC peering and limitations in what the APIs can do. And all of these things, like actually at this $250,000 mark, I should just go build a data center. I'm going to move faster. I'm going to have more ownership. I can do a lot more with my time if I just own more of the stack.
This is Sovereign DBaaS Decoded, a podcast for IT leaders and implementers looking to reliably scale database ops while maintaining control of their data stack. In each episode, we join industry experts to discuss the what and why of sovereignty and how you can implement the Sovereign DBaaS concept of your own using open source databases, deployment models, and tooling. Let's get started.
Hello and welcome to 2025's second episode of Sovereign Database Decoded. I'm Vinay Joosery, and this episode is brought to you by Severalnines. Our guest today is Justin Garrison, Head of Products at Sidero Labs. Thanks for joining us, Justin.
Yeah, thanks for having me.
So let's talk a bit about your background. I think you spent over 5 years at Disney and 3 years at AWS. So what were those experiences like, and what did you take away from them?
Disney was a very interesting large place for different reasons. I started in animation, and so I was doing infrastructure for the movies, for Moana and Frozen and those sorts of things, which was not something I'd ever done before. But it was very much a scientific computing sort of environment where there was a lot of HPC, on-prem, processes. And at the end of the day, what I realized we were making was box software. The product that we created was all the artists drew bits that would be put on a CD or a DVD, and it would go ship to a store and it would sit on a shelf, and it's box software. And the player, the software at the other end was being playing with like a Java Blu-ray player. But that was the process, and that's how we were getting things done. And it was fascinating because I loved being able to finish something. There was a moment when it's like, oh, I'm done with this movie and we can move on to the next thing. And I feel like a lot of people don't get that experience anymore, because then I shifted over to Disney Plus and I was doing infrastructure for Disney Plus before the Disney Plus launch and during the launch. And that was very much the opposite, where as soon as we were done with Disney Plus and ready to have people use it, that's when the real work started. That's when it got really busy and things shifted into high gear. Exact opposite of what we were doing at Disney Animation was when we were done with the movie, we'd all celebrate and then we'd move on. And Disney Plus we're done with the platform, we're done with the service, and now we really have to do more work. And it was just a very different sort of environment, which was a lot of fun to learn both, but also understanding like why process and tools are different. At Amazon, it was more of it was obviously a services company where I was in AWS. I was working on EKS. And so we didn't get the moment of that we're done with this thing. But the culture at Amazon was much more of a monoculture than it was at Disney, because all the different Disney divisions ran software and product and services all different. They all had their own kind of ideas around what they wanted. And you could go from division to division and have completely different tool sets and talents and all different things. But Amazon, it was very much one type of thing, which made it easier to shift between teams, but kind of harder to differentiate yourself, harder to say, I want to do something that I think would make a big improvement. It's like, okay, well, you got to bring all of Amazon along. And that was really, really difficult to make any sort of changes like that.
Yeah. And today you are at Sidero Labs.
Yeah.
So, what do you do there, and what does Sidero Labs do?
Sidero is the Greek word for iron. And if anyone knows Kubernetes, they know it's, Greek themed. And if you know iron, it's kind of bare metal on-prem sort of like infrastructure. And what I found at Disney Animation, I was doing on-prem Kubernetes for them. I was trying to build up their practices around containers. And then even at Amazon, I was doing on-prem Kubernetes, a lot of it with EKS Anywhere. So like doing the EKS Anywhere product, I kept coming back to this, on-prem allowed people to have more flexibility, allowed people to have more ownership and just be able to do more with what they owned and not have to rent it over and over again. And I was a big believer in that, coming from an environment where they owned data centers and they knew how to run the hardware. And I didn't think everyone should rent all the time. I enjoyed the cloud. I was using the cloud in multiple places. And one of the biggest things that I learned about Amazon was their best asset is marketing, where they can make everyone think that having a data center is a bad thing, but then you can praise Amazon for building data centers. And it's like, whoa, Amazon's like a really big on-prem company, and no one really kind of connects those things. At Sidero, we really focus on that on-prem side of it. We're just like, hey, let's just make the Kubernetes on-prem super easy. And coming from doing it manually at Disney, doing different products, really experimenting with what was out there and then building EKS anywhere. I was like, there has to be a better way. Like all of these things felt too complicated. And so Sidero really focused on making the underlying operating system dead simple to use with Talos, and then building on top of that and saying, okay, now if we have an API for Linux, what can we do with that? And it turns out you can do a lot of things that aren't necessarily automation. They're more like autonomous systems where you don't have to run a bunch of shell scripts in Ansible and Cloud Init and all these things that kind of tie all this stuff together and hope it works. It's like, oh no, we know what declarative APIs look like. Kubernetes uses them all over the place. And so that was kind of what they've been doing for a very long time. And I joined and want to keep doing that.
Yeah. I see the pronunciation is Sidero and not Sidero. Maybe the Greek word is Sidero. I'm not sure.
Probably. I mean, same with Kubernetes, right? A lot of the pronunciation doesn't transfer over between languages or gets it wrong. I'm not too caught up on how people pronounce things.
No. Yeah. Actually, I used to work for MySQL for a while, and I mean, people will get hung up on how you would say MySQL, MySQL.
Yeah, it's an age-old problem.
Yeah. So okay. So today we'll be talking about Kubernetes on-prem, starting with migration patterns to and from the public cloud, and also getting into the nitty-gritty environmental and operational details of running Kubernetes in your own environment, right? So let's get started. I mean, first, if we kind of roll back and talk a little bit about, the dream of the cloud, right? I mean, the move to the cloud, why has that happened? And at that scale, and I mean, what has been the effect of enterprises moving to the cloud?
Again, I think that the cloud marketing is amazing, right? The cloud is a single destination. Whenever anyone thought about on-prem, there wasn't like a single representation of on-prem because everyone's on-prem was different. And everyone's on-prem was broken in different ways. And we could kind of boil the cloud down to like, oh, it's the cloud, right? It's like the one thing that you really want. And all of those are also broken in different ways. So it's not like it's a new sort of thing, but it gives you a single target. And everyone can say, I'm moving to the cloud. Just like now, a lot of people are like, I'm moving to AI. And like, what does that mean for you? And I was like, I don't know, but we have to have it, right? Like people had to have the cloud. Some of them said, I wanted a private cloud. I want to own the cloud, whatever. They're like, I want the cloud. And really, they don't want the responsibility of maintenance. They don't want the responsibility of something long-term that they own. Just like if I travel to a city, I want to get from the airport to a hotel. I'm not going to buy a car. I'm not going to own the car long-term because I only need it for a short period of time. I just like, I'm going to call a Lyft. I'm going to go from the airport. I'm going to go to the hotel. I might get public transportation. But likely it's just like, I want the convenience of having a car. I just was on a plane for a while. I just want to sit down and go. And the cloud gives you that convenience. The cloud says, oh, cool. You can experiment with all this stuff. You can do all these things really, really quickly. You can get it instantly. It's just instant gratification. Just like, give me that EC2 instance, give me that database, whatever. And they say, I want that convenience. But the problem is like, if you're doing it long-term, if you really want to get a ride back and forth. If I'm taking my kids to school every day, I'm not getting a Lyft for that. That is so expensive. And it's actually not convenient anymore because I can't leave whenever I want. I have to coordinate with someone else. I have to request the car. I have to do all this stuff. And the cloud determines when you upgrade, right? The cloud says, we have your RDS instance. We're upgrading you. You don't get to make that call anymore. We have your Kubernetes cluster. We are upgrading that for you. You don't have any ownership there. You now have to coordinate with this other group that is part of, is critical for your infrastructure, but you don't own it. You don't have any control over those things. And so the convenient side of cloud is absolutely, everyone loves it. It's amazing. I'm not saying don't use the cloud. The cloud is very convenient. I'm still using Lyft to get to the airport, right? Those situations when I don't know how long I need this thing, I don't know how far it is, I don't know necessarily where I'm going, use something that's convenient, use something that's temporary. But once you understand, I need to do this every day, I need to run this, I need to be responsible for this, you need to then build up the skills to maybe go buy your own car, get a driver's license, pay for insurance. Those sorts of things are all critical to you having responsibility for having the flexibility you need.
Yeah. And I mean, what is the effect, right, of this move to the cloud? I mean, what has it done to the business in a way, right? To all these enterprises who maybe have moved significant portions of their operations to the cloud?
Even in a short period of time, a lot of businesses have forgotten what it actually takes to run something on a server. And sometimes that's because they sold all their data centers and they're like, I don't know how to start from scratch. And no one ever knew how to start from scratch because the data center was bought 30 years ago or something, right? Like that could just be lost over time. But a lot of developers also don't know the layer below where their infrastructure or their applications run. And they say, I don't know Linux. I don't know what hardware looks like. I don't know what a NUMA node is on a server. Like I don't care about all this stuff. And in many cases, they don't have to care about that stuff. But now businesses don't prioritize any of it. And they say, well, if that application is slow, I'm going to put more money there. I'm going to get a bigger hard drive to get more IOPS. I'm just going to rent a bigger EC2 instance because that's all I know how to do is throw money at the problem. I don't know how to actually figure out what's causing the problem and then how to solve it at a lower level. They just kind of abstract that away because they're like, that's not my ownership. I can't touch what's underneath Lambda. So my cold starts, I just have to run one all the time. That's the solution when you don't have access to those things. And a lot of companies are losing access to the things that actually can give them differentiators, to make them more performance, to make it so they can run more infrastructure or more applications at a cheaper cost. All of those things, they're just like, well, it's not mine, right? If you're renting a car, I'm not going to change the oil on it. I don't need to know how to change the oil. It's okay. But if the car breaks down or overheats or something, then I might need to fix it.
Yeah. And I guess also the way the market rewards, competence, I guess, being able to build your own network, using Cisco switches and routers and whatnot, instead of maybe, I don't know, configuring things in AWS. I guess the basic skills are not as prized today.
And just like the cloud is a single target for where people are moving, even if it means different things, certifications and training and ecosystem have done the same thing for people that are learning. People are saying, I want to get in technology. All right, go get your AWS cert, right? Like that's the thing that is like, that's the hope people have. And when you change what their view is of, I can have a better life, I can get a better job, I can support my family, like that, changing where their hope is a big deal. And I do think that having a single target makes that easier for a lot of people to align on what they're trying to do. And certifications, trainings, ecosystems, those all do that. It's just like Kubernetes does to a lesser extent, where it's like, I can get my CKA, whatever certification in Kubernetes, and maybe I can go get a job and do Kubernetes, and I don't have to do this Ansible stuff anymore. I don't have to do whatever it is that they don't want to do. Like the Kubernetes might be the better thing, so I'm going to go for it. And humans generally are really good at taking care of themselves in trying to build themselves a better future.
So that's how, we can see, we are now at a stage where maybe are we seeing reality, like cloud growth is slowing down, right? And then the question is, are we seeing a backlash, right? Or will we see a backlash to public cloud? For example, repatriation, right? Geico last year, right, spent a decade in a large public cloud, and then they decided it was too expensive and they were not getting the value that they thought.
Just Uber had backlash when people realized how expensive Uber was, and Uber started raising prices because their seed funding, or all their VC funding was drying up, and they're like, hey, actually, we just need to make money from customers now. So it turns out we can demolish a lot of the taxi industry and just pay for it based on VC funding. And now that we have captive audiences, we can charge them more. And there is some of that backlash because the cloud, at least when I was getting started in it, always promised we're going to get cheaper and cheaper and cheaper. And that hasn't happened for years, right? There hasn't been big sweeps of, oh, you know what? I didn't do anything and now my bill's cheaper, right? My last year at AWS, every company I talked to was trying to save money on their cloud bill. They're like, I can't afford this anymore. And not only because the infrastructure itself costs more money, but because they said they got rid of all the people that used to rack and stack servers and they replaced them with more expensive people that do FinOps, or they do something else in the cloud. Cause like, I have to pay these people more money that are basically, if you squint, it's kind of the same thing. They're maintaining and optimizing their infrastructure in various ways. And I can't afford this anymore. Like, why, how do I make this cheaper? And every customer I talked to, I wrote best practices, all this stuff around it. It was the same 3 things that I could offer you. It was like, okay, well, try to right size your EC2 instances, try to reduce your network spend, try to get reserved instances, and use Spot. And that was it. That was the most you could do. And I'm like, if you do those things, you might reduce your bill by 30 or 40%. And I just sat down on my own and I'm like, okay, how much would this infrastructure cost me to buy it and run it and host it in a data center? And I realized that somewhere around the $50,000 mark, if you were spending $50,000 a month and you could project that spend over a year, I could go buy a server and put it in a data center, and I could do it cheaper than what I was getting at AWS. And that was like the breaking point for me. I'm like, wow, there's a lot of companies spending more than $50,000 a month that know they're going to spend more than $50,000 a month for the next year or two. And they could make it cheaper, but that wasn't the real savings point. Cause that wasn't actually like, okay, well, like, yeah, for big companies, this doesn't actually matter. Then I started projecting out, okay, how much do the teams cost? And I started talking to more and more people, and it was somewhere around $100,000. You could save money on your people. You could actually say, oh, you know what? I could get a white glove service in a colo that I don't even have to rack and stack things. I could still rent some portions of this. I don't have to do everything manually. I don't have to plug in network cables and make it look pretty, even though some people love doing that. And somewhere around $100,000 a month, if you could project out your $100,000 spend, you could save money on people. And then people like Geico and Hey.com, and they were spending more. They were spending around $200,000 to $250,000 or more. And at that point, the cloud became a limiting factor where people started noticing, hey, you know what? I'm actually going slower because I'm in the cloud. This is taking me longer to do things because of the complexity of hundreds of AWS accounts and VPC peering and limitations in what the APIs can do. And all of these things, like actually at this $250,000 mark, I should just go build a data center. Like I'm going to move faster. I'm going to have more ownership. I can do a lot more with my time if I just own more of the stack. And those were kind of the interesting spots that I started noticing over and over again that companies were also shifting to. They're like, hey, if it's a small company, even people like a Zig, right? The Zig programming language, they had a couple servers, right? And they're like, I just need this to be cheaper. I'm not saving any time, but I just moved it out of AWS and I saved all the egress fees, and they cut their bill like 80% or something like that. It was something ridiculous by like, oh, this was just moving 2 servers somewhere else. And so even at the low end, it was interesting seeing people realize that just the cost of a big hyperscaler cloud, like I don't need all the features and I don't need to offset the cost of someone else running something that's cheaper. I just need an EC2 instance. I just need a VM somewhere. And that was just over and over again the whole year at Amazon. I'm like, I don't think the cloud is sustainable for a lot of people long term. It is incredibly convenient. There's a lot of people that are going to be there. They should be there. But if you're just planning this out and you make a spreadsheet and do the math, at some point it's not going to add up.
Yeah. And that's also one thing that we hear. Planning that cost is very hard.
People hate budgets.
It's extreme now.
And that's another thing is like people are like, I don't want to go back to yearly budgets. And it's like, actually, you know what? A yearly budget is really good if you need consistency, right? And that's what most companies need. They don't care how much it costs. The finance department just needs to know is what you're telling me this is going to cost actually what it's going to cost in a year. And in the cloud, with everything being on a credit card or dynamic, that predictability is gone. And if you can just give them, I bought these 10 servers. This is how much it costs to host them somewhere. This is how much my power costs, my cooling costs. Network's free, usage of them is free, all that stuff. This is my total cost. I will fit whatever I need inside those 10 servers. And in most cases, they don't actually care. They're like, okay, cool. Like that's all I want to put that line number down, and the whole business balance sheet works because I know that that's consistent. And the cloud completely throws that for a loop, and that gets really difficult because then you're reacting to things that are too expensive or trying to hire companies to save you money or whatever.
Right. So you mentioned something about building your own data center, on-prem, but is on-prem still a swear word? I mean, it's like you need to be a Luddite in a way to maybe you should be ashamed of running your on-prem infra because the cool people do it all in the cloud. That's like the way, we've been made to feel over the last 10 years or so, right? It's like the cool people are doing stuff in the cloud. So, so what's your thoughts on that? I mean, is kind of that is changing and maybe the concept of on-prem, maybe, moving to something like private cloud, right? Maybe we don't call it on-prem anymore. Maybe we call it private cloud because cloud is an operating model, right? Versus a destination. So yeah, what's your thoughts on that?
Just like I was saying before, the best part about AWS is the marketing, right? Like giving cloud as a name and making it a single place where people can go is fantastic. And as soon as you say on-prem to people, they say, well, what about edge? And what about something? It's like, well, like it's all kind of on-prem. And I like to call it grounded computing. It's like instead of the cloud, we're grounded, not because we are running on the ground, but because we're more realistic about what we need. And we say, I can predict what I need. And some of that might be in the cloud. Some of that is going to be a hosted service. I'm not going to run an email server. I'm just going to use Gmail, but I'm going to stay grounded about what it is what value I'm getting out of that. So that's the first thing. Like it's just making that a target. I don't think that saying private cloud also works because my VPC in AWS is also private. Right? Like what is privacy here? And it's like, oh, are we just going back to the old days of firewalls and egret, no one can see, no ports open on the firewall for, people coming in. Like, nah, that's not really what we mean by private cloud. What we mean is API driven infrastructure. What we mean is on-demand requests so that when someone says, I want to create something, I want to run something, I can do it in a way that doesn't require an email or doesn't require talking to someone. Just unblock me to be able to get something done. And again, as soon as we put private, hybrid, whatever cloud in the title, everyone just says, oh, then the actual target's the real cloud, right? Like you're like have a lesser experience of the cloud. And that's not it. Like that's not what we're talking about. We're talking about something different that is ownership and responsibility, but also flexibility in how you're using it and how you're consuming it. And historically, that's been difficult because someone says, I need to build something. Like, okay, well, go to the Dell or HP website, pick out your server and go email procurement. And then in a month, you're going to get it. And then in 2 months after that, we're going to unbox it and we're going to rack it and give it an IP and provision it. And then you can SSH into a host, right? And now you can do whatever you want. And that's not good enough. We know that's not good enough. And so being able to give people any sort of like dynamic infrastructure of I can just deploy something. My first introduction to Kubernetes was a Jira ticket internally at Disney that just said, allow the web team to self-deploy, not talk to anyone. They just want to be able to create an application and deploy it somewhere. And that literally led me down this whole rabbit hole of building out Kubernetes and saying, okay, how can we give them an API that does that? Do they want VMs? They didn't want responsibility of the VMs because they said like we would force them to do upgrades and test and all this stuff. And so I went to them, I said, hey, could you package your stuff in this container formats and then give it to me and I will run it somewhere. And at first it was just a manual thing and they just packaged the container, put it in a registry. I had a few VMs and I ran the container. I said, cool. You didn't have to email me. I could see that was being updated. I could see the Jenkins job, all that stuff. I just ran it for you, right? Like I was the orchestrator. I was the Kubernetes component of that. And then once I got comfortable with that, I said, okay, I understand how this works with 3 machines. Now let me do it with 5 machines in an automated way. Let me find an API that does that for me. And that was my whole path into this Kubernetes thing, was just trying to solve that as a business problem of making dynamic API driven, no emails sort of infrastructure.
Yeah. So then, if I, let's come back to this on-prem versus private cloud, then it is really on-prem. We should not really think private cloud, in the sense that private cloud will, it alludes to like the real public cloud in a way. It's pretty much same.
I feel like if you call it a private cloud, everyone says, oh, you should go pay for the real thing, right? Like you have a private cloud because you can't afford the real cloud, or you're not cool enough for and the cloud does really cool stuff, right? Like the amount of scaling and all those like demos, like, you can't do this on-prem. It's like, yeah, you're right. I can't. Like, do I need to? Does my business actually need that? I don't think so. Like, I don't think I need to scale 1,000 nodes in a minute, but okay. Like that's really great for you. I love that exists for some people that might think they need it. But even like Disney Plus, like we launched Disney Plus, we had 10 million signups in a day. You know how we did it? We pre-scaled everything for 3 weeks. We just scaled up everything, all the load balancers, all the VMs. We said, oh, actually, we know we're going to get a big hit on launch day for Disney Plus. So let's just like take the estimates we have of how many users, do a little bit of math and say, okay, well, we're just going to scale all this up by however much and just leave it there for weeks beforehand, just to make sure that we get the capacity from the cloud, because you don't get capacity all the time you need it. We're going to warm the load balancers because AWS requires that, which you don't usually require other places, and just let it sit. And we just spent an extra, 60% on our infrastructure for a while until Disney Plus launch settled down, and then we could scale it back a little bit and say, okay, this is about where it's settling down. Let's scale back to the actual numbers.
Yeah. So, regardless of where, people decide to place, let's say their racks and to operationalize them, their own DC, or maybe in, colocation, what are people using today to build their own?
All of that. Right. It's like, it's a mix of all of those things. And it depends on who you talk to, which one they're using the most, right? Like when I was at Amazon, everyone we talked to was using Amazon. I'm using, now at Sidero, everyone is using on-prem, or they're using a not hyperscaler cloud. They're like, oh, you know what? Like this OVH cloud or Hetzner or DigitalOcean or whatever, they're all cheaper, and all I need is the compute. If you just give me computers, I can do whatever I want with them, and they happen to cost 60, 70% less than the EC2 instance that was the same, right? And so it's like in those areas, they're just like, oh, well, I need it this way. I don't need all of the bells and whistles of this thing. I know what I actually am going to use it for. And, for us, it's Kubernetes clusters. We're like, actually, Kubernetes solves all of those cloud layers for me, where I get the API, I can do the dynamic scaling, I can do all the stuff that maybe I thought I needed out of AWS. I can just put those in the Kubernetes API and I'm good.
Yeah. What about the old players like, you have VMware, which used to be king and is still massively used. But then you have newer ones like, Nutanix. You have these platforms like, OpenStack, CloudStack, Proxmox. There's a bunch of them. What about those ones?
Yeah, even KubeVirt, right? Like all these,
Really?
we're reinventing a lot of this over and over again of like, what's the API you actually need to do something? And there is some difference there with some of those are open source. Some of them are hardware appliances. Some of them are, software you run on whatever you own, right? And those 3 dynamics are options. And it's good to have those options to say, actually, I don't have any hardware, but I have a partial rack somewhere in a colo. I can get Nutanix, plug it in. I don't have to worry about doing the installs because maybe I don't have the skill set to maintain some of that stuff. VMware was always the play of you run it on your hardware, right? They don't sell you a box. They license it based on, what your hardware is. And it was a way to utilize more of what you bought, right? Get more out of the thing you already own. The whole reason VMware exists is because we weren't utilizing the hardware we were buying. And we say, oh, we can carve it up into smaller bits and then you can use it more. So you're just getting more out of that investment. And things like OpenStack and CloudStack and the other open source ones were all about just freedom of responsibility and ownership. Like, hey, you know what? I can own this wherever I need to run it. And I can install it you only install it on your own hardware. Or you can get a service, like there's Rackspace and things like that do run it for you. But the idea is I might need this portable at a different layer. Because one of the things a lot of people think about Kubernetes is like, oh, it's a portable thing, right? Like I can run this wherever I want. I can run it on-prem, I can run it in the cloud. And then all of my applications are portable. And it's not really like, every environment is a little different. Just like OpenStack, every environment is going to be a little different because there's different constraints and requirements. But if you have the skill sets to do that and you need that much flexibility, then you go to that end of the extreme, right? You say, okay, well, I'm going to run everything open source. There is a lot of these other clouds that are like self-hosted cloud environment APIs that aren't open source. That seem a little weird to me, where it's like, okay, you're not quite a VMware. You're not as good or well known as VMware, but you're not open source and portable like OpenStack. So you fit somewhere in the middle there. And the people that decide that are just like, I just either need to get off of VMware because the bill now, and I don't really care about the open source stuff. So like there's this other, piece in there. But all of them are just on the spectrum of what do you actually need? What are your skill sets? And do you want to consume your infrastructure with an API in some way to make it somewhat dynamic, but all of the process and practices around that usually restrict people because we're not giving admin access to create VMs to the devs, right? So they're still like, oh, well, no, you have to talk to me, even though the API exists, which again is a big reason AWS in the cloud has been successful because we actually gave all the devs admin IAM access. We said, go have fun. It's all on this credit card. Right. and just don't go over this, don't go over this amount or whatever. But in on-prem, we said, go have fun. We already paid for it. You can't trust them to restrict themselves because they're going to consume all of the resources and then someone else can't run something. So this is, difference between how they function. And in one case, I can say, oh, I can just cap your bill and say, I get alerts whenever you go over $100. On-prem, I can't do that because I already paid for it. I don't know when you go over $100. Is that an amount of time? Is that an amount of resources? Whatever. We have to have a way to restrict them. And so usually that's a team and a process that restricts them, not a technology.
No. But Kubernetes is a viable alternative today to fully build your own private cloud if you have a bunch of machines.
Yeah, and Kubernetes sits at a different layer. Kubernetes it can control or at least call the APIs for infrastructure. But really Kubernetes is kind of above that, where it's just like, just give me the compute and I'm going to run somewhere and I'm going to coordinate things between that. But all of the other like, oh, give me a load balancer, give me another VM for auto scaling, whatever. Those are all just like calling those APIs. The APIs exist and Kubernetes is just like, oh, I'll interact with them. But Kubernetes is kind of dumb. And it just says, oh, look, a load balancer's here. Oh, I'll connect it to that label, right? It's not doing a lot of the work outside of just, you give me an API to call and I can call it. And it sits at that different layer, which also gives us a little more freedom, where I don't think a lot of people have been constrained by the idea of data centers in regions and VPCs. And they say, oh, I have a data center here, Kubernetes runs here. I have a data center over there, Kubernetes runs over there. Same thing with regions, right? Like you have regional clusters. But really, it's just this layer of compute orchestration that says, oh, wherever you give me machines, we can run it there. And that was one of the really cool things, like starting at Sidero, where I realized that they had technologies, like we have WireGuard networking just built into the OS, and we can just talk to another machine wherever it is, right? We can, WireGuard is a, low latency VPN. And so you can solve problems in different ways that aren't constrained to regions and data centers. And you say, if I can coordinate a bunch of infrastructure all over the world, I can do that in a different way because Kubernetes as the shim layer isn't actually constrained to those things. Whereas a lot of times the cloud providers, and historically people have said, you have to run it in this location. I'm like, no, that's not actually how it works. You can do different things with it.
Yeah. But I assume that you are able to have some kind of locality. Like if you want to say, okay, maybe, these databases, I can only run them in this in this region, or I'm going to do, let's say, redundancy with my containers, but I can't have the backup, being spun up on the same machine, right? I want to have, my redundant node somewhere else.
Yeah, that all comes down to what the application and the business needs, right? Whatever their risk profile is, to say, I need redundancy. And in a lot of places, like in the cloud, they're like, okay, well then you should be across multiple AZs, because those are data centers. Some people are like, no, I need it across multiple racks. I want to make sure that that power profile on that rack is different than this one. And yeah, they're not on the same box. They're in different racks. You can even go down to like different NUMA nodes, right? You're like, I need this to run on a different CPU set than that workload, right? Like whatever it is, like you can have that flexibility down to that layer. But then also you could say, oh, if I need high availability across data centers, then yeah, I can place the workload. I can say, oh, spread this across data centers. And if I label it properly, I can do that.
Yeah. So let's assume, the enterprise has been running in public cloud, and it's decided it's not getting the benefits of the cloud, right? So high costs, lack of control, whatever. So what challenges will they face when they're building and running their operations, right? For this on-prem, let's say, slash maybe private cloud. Well, I shouldn't say private cloud. And is there a way to reduce these, right, through simplifying certain choices, right? Like, choosing something like containers.
I mean, if they're already containerized, sure, like keep doing containers. One of the benefits of moving to the cloud that a lot of people did was they just picked one or two services to move up there first. And they just said, we're just going to slowly trickle some things up there and then figure out how they work. And the bigger benefits a lot of companies got was the process change over the technology changes, where they said, Dev, you get your whole account. You do whatever you want, and we're just going to look at the bill at the end of the month, and we're going to set some alerts. We might set some restrictions, but you get the entire thing, and you need to run it, which they didn't do on-prem, right? They maybe gave them a server, but there was still a team behind them that was doing the monitoring and updates and racking and all that stuff. They didn't give them a box and say, go rack this and go have fun. In the cloud, like moving out of the cloud is a very similar thing. And I would hope that people don't fall back to the old on-prem sort of process where they say, okay, now if you want access to something, you have to SSH into it. We got rid of all the APIs, right? And that's the thing that a lot of on-prem environments restricted. And they said, oh, if the server's here, we want you to be able to go touch the server and push the power button if it gets stuck. In the cloud, you can't do that. And so we had to build process around how do you get access? How do you debug a system that you can't push a power button for? And the cloud might give me some of those virtual buttons to, yank a power cable or something. But in general, I had to build a better process around what would it look like if I don't have access to the machine? And that was actually the co-founder for Sidero. Like Talos was built to remove humans out of that loop, and specifically on-prem, where all of Talos is an API. It's all API driven. There's no SSH. There's not even a concept of SSH inside the system. And so if you want to configure or debug or do anything to the system, you call an API. And that API exists to do everything you would need, including bonding network adapters and setting up hard drives and running workloads. And all of those things are at a machine level, this API spec. And we say, hey, if everything's an API, what do we use on top of that? And it's like, well, Kubernetes is a great orchestrator. We can do everything above Talos is Kubernetes. But yeah, coming out of the cloud, if you have Kubernetes and you have containers, then you're ahead of the game. If you have VMs, again, I'm not saying give it up, right? Like you could use VMs on-prem. You can do a Nutanix or an OpenStack or VMware, wherever you are in there, and say like, is my VMware bill really high? Yeah. How much was your cloud bill? Right? It's like people are saying how much more expensive VMware is and not actually comparing it to something else that would be comparable, and saying like, actually, maybe VMware is not so expensive if I was looking at moving to the cloud, right? Like VMware is cheaper than AWS. So I'm fine, but that's not how most companies think about it. They just say, I need to cut this bill by 10% or 20%. Doesn't matter if it was more expensive with our, proposed shift to the cloud or something. So they just say, okay, well, where can I save money? And in most cases, it's like, okay, well, you either utilize the thing you already have, or you buy cheaper versions of the thing you have, or you get rid of people. And unfortunately, a lot of companies are just like, well, the people are the most expensive part, so I'm just getting rid of people.
Yeah. Yeah. Can you go 100% cloud native, right, and run Kubernetes as your operations platform, right? And if so, would it even make sense? Red Hat has been pushing OpenShift virtualization, right, based on KubeVirt. And is that more of a bridge play, so you can run, legacy VM workloads on KubeVirt, and then, the rest of the stuff cloud native?
Like you said before, cloud is more of a state of like a mindset of how we're working with things, of how we operate things and how we control them. And people often forget that the cloud was born with VMs, right? The high praise of Netflix being one of the early cloud adopters was they built golden images of VMs. And we all said they were cloud native. We all said 10 years ago, 15 years ago, Netflix is doing it right. And they're building AMIs and they're deploying AMIs to auto scaling groups. And those are cycling through and replacing themselves. And it's a VM game. The package changed from an AMI to a container with Kubernetes. And we say, oh, now Kubernetes has to do it all. I was like, not really, right? Like VMs are still a part of this API spec. And if you manage them in a cloud-like way of saying, I need this to be dynamic, or I need to have someone, the ownership of that to be an API call, not an email, that's a big deal. When I was writing the book, Cloud Native Infrastructure, we went through that history. We started talking like, hey, all of these people that are running cloud native stuff, they're all doing VMs really, really well. And this isn't because that they're all in on, most of them didn't even have any Kubernetes at the time, right? They're just like, oh no, that Kubernetes thing is like, maybe we'll get there. But VMs and the process of building artifacts and deploying them and making sure that side of it was healthy and deployed in an automated fashion, that was the cloud native bits. It wasn't the Kubernetes and containers. I don't think that everything will ever be Kubernetes or should be Kubernetes. I'm a firm believer that you shouldn't make all problems Kubernetes problems. And that was one of the things that I really disliked about EKS Anywhere, where every time we were building a new system, we would put it in Kubernetes in this management cluster. And I was like, why are you making all this Kubernetes problems? Like, that's DNS. Like, don't make DNS like your actual like DNS mask. Don't make it a Kubernetes problem. If I want to debug DNS, let me just go find where it's running and tail the logs, right? And I don't want it to be dynamic. I don't want it to auto scale. I don't want it to shift machines. I need things like DHCP and DNS and a lot of times databases. Like, I need those just to be like in a certain state that I can understand. I don't need all of the flexibility dynamic stuff that you might get out of stateless web applications where we say, oh, we should treat everything that way. I'm like, no, you should not. Mm-hmm. I don't think that Kubernetes clusters should be ephemeral, right? There's too many things that point to a Kubernetes cluster. Like, there's DNS externally, there's load balancers externally, there's storage externally. And people say, I can destroy my entire Kubernetes fleet and then rebuild it with a single command. And I'm like, well, what about all the other stuff that exists? Like, that's not, that is a bubble of infrastructure that can be redeployed. But all the stuff outside of that, you can't do these sort of like blue-green deploys with like multiple Kubernetes clusters a lot of times, because like, well, then how do you rotate DNS? How do you shift your load balancers? How do you move traffic from one machine to the other when the customer outside calling DNS, it like, who knows when their cache expires, right? You have to run both clusters for an undetermined amount of time until you know for sure, like, oh, now it's just more expensive. And now it's more work to do that. And a lot of people that, again, they just try to go all in on Kubernetes, and it's a tool. Like, we should use it for the things that it's good for and not necessarily try to put everything as a Kubernetes service.
Yeah. And you actually mentioned, even databases. So what about them? I mean, you can theoretically, you can run them via operators, right? You can keep them maybe running over, on your VMs via KubeVirt, right? Or on your regular VM environment that you have, right? What do you see out there?
The main thing with databases is they're not web applications, right? They're not stateless applications that I can just throw wherever I want and put behind a load balancer. I have different requirements. The closer I get to data, to bits on disk, the more paranoid I should be. And in a lot of cases, that paranoia means I might want to SSH into a server and run this manually, so I know how that works. Some people, that data isn't as critical, right? Like if this data is down for a few seconds or a little while, or if I need to do a restore backup, I'm not losing the business. In those things, absolutely, it's okay to be able to trust someone else's software to maintain that database for you. We've been doing that for a long time. Before operators, there's been database managers, and there's been things that would babysit and make sure that databases would fail over properly. There's all this software that we didn't write that maintains and manages databases. But the more important it becomes, the less willy-nilly you should be with that software and say like, actually, this one I'm not going to put in Kubernetes until maybe I trust it enough or I have enough practices around that. And I see this shift from both sides where a lot of times databases are getting better at being containerized and being more dynamic. And we look at things like CockroachDB and in different databases that are like, oh, you know what? We were designed to horizontally scale from the start. And we were designed to lower your operations requirements so that new nodes joining and leaving aren't a big deal.
Yeah.
Older traditional databases are not like that. And we have to be aware of why they were built, how they were built. And we can't just call it an operator and say it's all good now, right? Like, oh, this operator is going to fix everything for me. It's like, no, you should really have a skilled person that is your operator at some level, right? Like if you have a software operator, you need a person operator that knows how that works. And you can't just trust everything to this CRD plus a control loop. And so again, at that layer, we pay DBAs. We should be paying DBAs money, a lot of money, because that is the most critical part of most businesses. And again, it's just one of those places where a lot of companies, maybe they're short-sighted, maybe they just see it as a cost and like, actually, these databases have been running stable for years. Why do I need a DBA? Right? Like, well, maybe they've been running stable for years because of your DBA. Maybe you should look at that side of it. And that is like a different conversation, but it's really hard because no one ever told anyone, good job for running servers that didn't fail, right? It's like, oh, no one ever, like, back to the sysadmin days. No one's congratulating you on not having an outage. They're just saying like, this should work, just like a light switch in my house, right? Like it's only surprising when I flip the light switch and the light doesn't turn on. And I say, well, now what's going on? Like, why isn't that working the way I expect it to all the time and be stable and 5 nines of light switchability? This should work. And in an infrastructure, we keep going back to this, like, how much reliability do you need? How much investment do you need on that? How long are you going to run it? How much is it going to change? All of those things determine how flexible your process needs to be, your software needs to be, and how much of it you need to own and write. Because a lot of these companies, a lot of the enterprises are writing a small percentage of all software they run. That's just like fact. Like they're not writing operating systems from scratch. They're not writing load balancers. They're not writing Kubernetes. Like the amount of software that they run that they are not owners of is very large compared to the amount they're running. They're just gluing it together and they're saying, I trust someone else. I trust this open source project. It has 100 stars. I should run that in production, right? Like that's like the barrier for a lot of people now. Like 100 stars, we're good. I'm going to run their operator. I don't need a DBA anymore, right? Like my SQL is good and we can operate it from that. And then it breaks and they say, I don't have the skill set to fix this anymore. I have to open a ticket or I have to go hire someone and do something to figure it out. And so databases, again, I wouldn't treat them like web services the same way and say, actually, these are stateful and I care about this data. If you don't care about the data, sure. Right? Like I've thrown away plenty of, data that's like, oh, I lost a day of metrics. It's okay. I recovered. Those sorts of things are fine. But when you really get down to like the important data, just make sure you have someone that operates the operator.
Yeah. I mean, I must say that, we see less and less DBAs, because I don't know, maybe there's more databases and now you have, you have DevOps, you have SREs, you have all types of titles, handling databases and they're getting more and more, let's say, general purpose, right? People who do not just databases, but they do a bit of other things as well. But coming back to the database operators, right? I think it's interesting that you said that anybody running an operator should really understand what's going on there, right? So that they can fix things if things break. But the operators themselves, are they complete as in, do they do everything for you, right? Because day one deployments are fairly simple. You're not deploying the same database every day, but then you have day two, right? Yeah. That involves the entire life cycle of the database, right? You have upgrades, auto failover, repair, scaling, backups, point in time recovery, and so on, right? I mean, what level of automation do we have in today's operators?
All of them were built for different reasons, all of the operators. And even if you look for like a Postgres operator right now, there's at least 5 that I know of that all have different trade-offs around, we built this one for this environment or for this type of data or this use case. And we had to fork the old one because whatever reason, right? Like all of software is expanding. There's been an explosion of new types of databases that a lot of people became aware of. I feel like in the last maybe 8 years, where it used to just be, we have SQL and NoSQL, and that was it. And we say, actually, SQL is the one that businesses and enterprise uses. NoSQL is for the hipster web devs, and NoSQL had less operations. So people started gravitating towards that because like, it's easier to operate because you do everything in software. I was like, well, like, is that actually what you need though? Is that the performance you need? Do you need that large scalability? I don't know. Like, let's figure that out. I remember shifting a SQL database to a time series database for what I identified as time series data. And I said, wow, it was a 4 terabyte SQL database that they would load once a year to get reporting out of. And I'm like, what are you doing? Like, why don't we put that in a time series? Like, we had to have X, Y, and Z. We had to do something like, what are you actually reporting on? If I can run your reports faster, let's figure that out. So I literally migrated all the data and it went down to like 3.5 gigs. It's like 4 terabytes to 3.5 gigs of time series data. And then they could run it all the time. They could run their queries that had all the granularity of details that they needed for the reporting. And I was like, okay, well, like, we just don't need that thing anymore because this new database exists. Right. And people keep shifting around new types of databases and realizing that sometimes their data isn't fit for a certain thing, which also changes their requirement on how they run it, the operator side of it, the long term, like day 2 is the longest day of your life. Like we could deploy something day 1 and we're like, oh, this works. And then day 2 is the forever now, right? And like that side of it gets really, really difficult because it just stretches on until the application is no longer needed. And a lot of companies are not good at retiring applications. A lot of companies are not good at knowing when to turn things off. And that is another difficulty because they say like, well, now we just need to maintain everything forever. And so of course our infrastructure bills and everything else is going to always go up and not all those things are maintained forever. And so we have to either change versions or we have to manage it new ways. So the day 2 side of it is the important thing. And a lot of operators focus on the day 1. I can get you 100 databases in 10 seconds. Cool. I don't need that. Like I want more 9s over 5 years, right? Like that's the actual thing I want. And so there is some maturity that's happening in some of that because operators are still like a new-ish thing in Kubernetes where it's like, I get this CRD and a control loop. And as the Kubernetes APIs mature, some of those things work differently where a lot of the operators were built on beta and alpha APIs. Those are things you maybe shouldn't run in production, but Kubernetes has a long sort of maturity cycle for getting those things to production. Like, I need this today. I'm not going to wait for 6 more Kubernetes releases for it to be stable. Let's just ship it and then we'll figure out how to change later. And that is a process that like people aren't good at. They make the decision today. It's someone else's problem in the future. And choosing, I wouldn't say like the right operator, right? Like those things don't exist. You need to have someone that understands what you're building for, an operator for the operator to just say, this is what we actually need today. Let me make the right decision today. I might have to change that in the future. Let me make sure that the process and the understanding and the documentation and runbooks and all that supporting stuff around the application is good enough for tomorrow.
Yeah. Yeah. And actually, from what we've had some other guests in the past talking about Kubernetes, and there's an encouragement that you bring in the operator, but you should really fork it, because every company, organization, they do things their own way. So what you mentioned, maybe there are 5 operators out there, and maybe they made decisions because they had specific reasons why they wanted to use this and that, and maybe you don't want to do the same, right? So from that perspective, maybe you also understand where whatever you're using is coming from, and then also be prepared to fork it so that it fits your own kind of operations.
And I mean, people do that all the time with Helm charts and different things. They say, this is the thing I need today, and I don't want it to change on me tomorrow if I'm not ready for it. The problem a lot of them get into is tomorrow ends up being 3 years, right? It ends up being this difference of time that they didn't expect because they just ran out of time. They're just like, actually, I can't look at all that stuff. A lot of platform engineers I know are just looking at like support matrices of YAML. And they're just like, oh, this version of Kubernetes with that version of core DNS and this Argo CD and that. And like, they like do this whole chart of what supports what, because we froze everything in time, which is probably the right move if it's production requirements, because Argo's not doing that check for you. Argo doesn't know your environment, right? And core DNS, they do enough checks to get something inside their sphere to work. But as you have 10, 15 services supporting your Kubernetes cluster, no one's checking that in open source. That's your responsibility. But you need to be responsible for making sure you move it forward enough to always keep it up to date. And that's just maintenance. That's just the job of a sysadmin, right? This is like age old question of like, we used to have, like VMware stacks and even Exchange servers. I was responsible for like Active Directory and Exchange. Like, okay, well, what version of Windows could I run? What version of Exchange can I run with this version of AD with these features? And I had to do that work. I just had to do that chart. And Kubernetes is the same thing. Like, we didn't change this any different. We just write YAML instead of click through wizards. And it's all kind of the same ideas of being responsible for your software and making sure it's not going to cause an outage, because that's the thing you're risking, right? Like, oh, if the website's down, we're losing money. And it's my fault. I don't want that. And a lot of times it's the same thing in a different skin.
So, looking at Kubernetes, I mean, I guess many would probably start off playing around with public cloud services, right? EKS, GKE. And then maybe they would say, hey, let's just go all in and then use this. Okay, we've been consuming this as a service, and now we want to manage it ourselves, right? So from that perspective, let's say, what is the difference, right? When you actually have been consuming it as a service, but now you want to manage it yourself, right? In your own, private environment, right? What are the sort of day-to-day limitations you might, you might encounter when running it like in your own, sort of boxes?
The same thing goes for any proprietary software. That if I want to move from Microsoft Office to LibreOffice, like an open source option, that I'm probably not going to look at all the code, right? I'm just going to use it. I'm going to be a consumer of it. And when I move from something like a proprietary, because all of those hosted services are proprietary services, just like start there, where a lot of people are like, oh, it's Kubernetes, so it's open source. I'm like, no, there's nothing about GKE and EKS that is open source behind the Kubernetes API. All of that stuff is proprietary. You don't get to see any of that code. You don't get to touch it. You cannot run that in your data center. There are flavors like EKS Anywhere. I did not like the branding, because I'm like, there's nothing that looks like EKS Anywhere that looks like EKS. Those are completely different things. EKS Anywhere is entirely different. EKS behind the hood is a bunch of Lambda functions and step functions in EC2. And it's like, that is how it's built and that is how it runs. You are not going to replicate that somewhere else. But if you're moving from any proprietary software to an open source thing, the first thing you need to look at is like, what do I need? What is my requirement for a word processor? And if all I'm doing is typing words in a box and maybe printing it occasionally and adding a little bit of formatting, I can go pretty far on any of the open source options. I can go far in a text document, right? Like I don't actually need Microsoft Office to write Markdown, right? Like I can write Markdown, I can render it, and it's good enough for what I need. And that's usually the first thing. It's like, what are you actually using out of this? What do you actually need out of this? How much of the proprietary service operations are you relying on versus what you need to do? You are now responsible for upgrading the database. etcd is a database, and people say that's why they use hosted services, because etcd is a difficult database to run. And they say, I don't want to be responsible for that database. I don't want to hire people for it. So I'm going to pay Amazon to do it for me. I still frequently claim that Kubernetes would be run more places, not hosted services, if etcd was not the database. If we said this was all SQLite, the amount of companies that are comfortable running SQLite they're great. They're like, this is a file on a disk. I know how to back that up. I know I have some SQL experts. I know enough SQLite that I could run this and not have to run a managed service. I was not in the room when Kubernetes was built for etcd. I know that Google wanted high availability across data centers, and SQLite could not do that. But also I know that Google doesn't use etcd. GKE is not backed by etcd anymore because it's a difficult database to maintain. It's not the thing that they run, because like, actually, we don't need this database. We have a different internal proprietary database that is more performance, better scalability. We built it all from scratch. We know how that works. So we're going to shim Kubernetes to our database. We're not going to run etcd. On-prem, you're stuck with etcd, right? Unless you're doing something like K3S, which has a SQLite option. But then people say, oh, I want the high availability. I want to do all this stuff. And they kind of shim all this stuff into SQLite to say, oh, well, now it's high available. At some point, you just have to get comfortable with running a distributed database. And etcd is that database. If you want to own this, now you have to say, okay, how much of Kubernetes do I rely on? How much of it do I need? Do I just need web applications to go between servers? Easy. Don't even worry about it, right? Like your database isn't going to fill up. You're going to get enough performance. You're probably not auto scaling it. Even auto scaling isn't required for a lot of people. The amount of companies that I talked to at AWS and said, you just spent 6 months figuring out your perfect auto scaling, and you're only changing like 10 machines a day. Like you could have saved all that time and just pinned it at 10 machines and not even worried about it, and saved 6 months of your effort, which costs you more than any of the savings you're getting out of scaling up and down by 10 machines. And people look at these things and say, I have to auto scale because that's how Kubernetes has. I'm like, no, you don't. You just do static machines. Just, you have a few hardware nodes, and you can just, if your workloads fit, you're good, right? My first cluster was 6 nodes, didn't auto scale. It was all hardware. I didn't even run a CNI, a network interface, because I didn't need it. All I had was static routes. I just went to each server and I said, any IP in this block, go to that box. I knew which box had the routes. I didn't need a CNI. I didn't need to upgrade it. I said, this is how we can do this in a responsible way, because I don't need dynamic scaling up. I didn't need this infrastructure that was going to change a lot. I was like, no, I just needed an API for the developers to deploy something, and everything else under that was static, and it was fine. So that's really the concern that a lot of people, they look at what is possible and they say, I have to have all the boxes. In reality, say, what are you actually doing? What do you actually need? And let's start there and then figure out, okay, if this is all you need, maybe they don't even need Kubernetes, right? Like maybe some bash scripts are good enough for them. And that's great because it's just going to lower the operational cost. I'm not saying everyone should be doing bash scripts. I've shipped a lot of bash to production and I'm not proud of it. And it was hard to maintain, right? Like getting the practices and the common features of Kubernetes is a good thing because again, that ecosystem helps you solve problems, just like the cloud, right? Like I can search for anything about EC2 and I can probably find my answer. Same thing with Kubernetes. I can't do that for my own bash scripts. So being able to bring people on board, and you don't have to have all the expertise, but you have to have enough expertise to find the solution to your problem, is a great place to be. But don't think that Kubernetes is the new Terraform, right? Because a lot of people, they jump into Kubernetes and they say, I want to run crossplane because I want everything to be in Kubernetes. I'm like, don't make everything a Kubernetes problem. Don't put DHCP there. Just find the things that are like, is this painful to operate? Do you want it to be more painful to operate? Put it in Kubernetes, right? Like that trade-off is like, okay, well, like, do I want it to be dynamic? Like, no, actually, some things should just be static. And that is great. And so being able to make those decisions is really difficult, especially as people see new shiny tools. So operating it yourself is more about figuring out what you need than it is about, I need to now build out whole teams and process. And I was like, you have a DBA? Tell them, help them do some etcd training. Like get them an etcd cluster to play with and let them break it a bunch of times and see if they can fix it. Right. And so, okay, now I feel comfortable. Can you restore a database dump from etcd? If you can back up and restore, you are 80% of the way there, right? Like that is what most people do with any database that fails, right? Like, hey, this broke. I'm going to restore from backup. And if you can do that for etcd, like you're pretty close. Right. This isn't a big lift from that. The last 20% might take you longer because there's a lot of edge cases. There's a lot of things you don't know. But just to get, I can back up and restore, and our downtime doesn't have to be, 1 second. It's okay if it's an hour. Cool. Yeah. Like solve that problem first. And don't think that you have to like run all this stuff at Sidero, we try to make that as easy as possible. Like etcd is built into the operating system. It's not a layer on top of Kubernetes. It's not a set of other machines. The operating system is only meant to run Kubernetes. And we say, actually, we can reduce a lot of your headaches by just saying this only works with Kubernetes. This is a single purpose operating system. It just runs etcd and it runs containers and some of those in containers, right? Like it's doing this in a way that's like, hey, we baked in as much of the operational excellence by deleting all the stuff we didn't need. We didn't actually need systemd. We didn't actually need SSH. All of that stuff was just like, okay, if this is all we have, we can bake in the things that are common practices by default. So when we do an upgrade, we know when the last node comes in, we're going to do a database migration, right? Like those things are just like, okay, well, yeah, we change versions. We know how that works because that's all we do. And so that side of it makes it super clear of just like, okay, I don't need all that stuff and I can reduce the things I'm responsible for by using single purpose things, by using some of the common practices of backup and restore.
Yep. Can you give us an idea of the landscape, right? I mean, Sidero is one. I guess you can use Rancher. The market leader is probably OpenShift, which I assume is a beast to operate. What's out there?
You're right. Like OpenShift is the big one, right? With like a lot of market share, mostly because of Red Hat, right? Like Red Hat has been around for a long time. They've been the enterprise Linux for a lot of people. And so when they sell you something, you use it. I've been an operator of a lot of Red Hat software in my time, and all of them, I'm not a huge fan. Like, I've done a lot of upgrades for like Satellite and, Catello and their directory services and various things that were just like, these are big monolithic. They feel like box software in a not good way. Sometimes where I'm like, okay, this is kind of dangerous and I have to run this giant bash script that's going to hopefully finish in a few hours. Right. And I have to watch the logs for half my day just to make sure that this thing is going to work. And OpenShift's come a long way, but it also does a lot that people don't need. Right. Because again, this is like a huge system that didn't start with Kubernetes, right? Like OpenShift had their own concept of containerized applications. They used to call them cartridges and gears. That's when I was running OpenShift, was back in the day of pre-Kubernetes. And they kind of took a lot of those ideas they had and moved them forward into this big giant thing that they say, hey, if you want the all-inclusive Kubernetes package, OpenShift has it. Because they're going to bring you Jenkins for your CI/CD. They're going to bring you a custom command line. They're going to bring you build packs that say you don't ever have to write a Docker file again. They're going to say, we're going to do so much for you that your teams don't need to know how it works. And many, many people are successful with that. But also a lot of people they need more flexibility. They need to be in the details. They don't want to use Jenkins. They don't want to do something the opinionated OpenShift way. And that's either because they have teams of people. They're like, I'm not going to run my VMs there because I have VMware, right? Like I don't need your KubeVirt. I have VMware. We have a whole team around it. It's stable. It's big, whatever. Like There's a lot of reasons that you don't need all the bells and whistles. And it's also really expensive, right? Like that piece of software is the thing that makes Red Hat all of the money now, right? It's no longer enterprise Linux. It is no longer subscriptions. It is OpenShift. OpenShift is the money maker for Red Hats. It's a big thing. It makes them all the money. And that's great for them.
Yeah.
The other side of it is folks like Rancher. There's a handful of like smaller-ish companies that are like, oh, we have this thing, and EKS Anywhere, Google has a thing. There's some that are attached to a cloud that are like, hey, the reason this exists is just to make you move to the cloud someday. That's all. That's why EKS Anywhere exists. I didn't like that, but that was why there was always like, oh no, we need to get all these on-prem people into the cloud. I'm like, why can't the on-prem people just be on-prem people? Like, no. We're going to make it so easy to consume the AWS stuff that they're going to want to move to AWS. I'm like, that's not why I want to do this. I just want to make it easier for on-prem people. And so there's that whole notion there. And then the Ranchers and the other handful of people, all of them collapsed onto this cluster API. And cluster API is a way of managing Kubernetes with Kubernetes. And in the co-author for my book, Chris Nova, she started that. She started this idea of what if the controllers could create Kubernetes clusters. She had a project called Kubicorn, which was like a way of bootstrapping Kubernetes with Kubernetes. That started, she was doing a lot of COPS back in the day, K-ops. It was like a way to run Kubernetes in AWS before EKS existed. And so she was a maintainer of that. She went and did this Kubicorn thing and then started Cluster API and said, okay, this is the idea of all of your Kubernetes clusters are Kubernetes resources. And if you know how to use Kubernetes, this should be the best thing for you. And it's a very complex system. It's anything like Kubernetes, once you add a bunch of controllers to it, you have to go find the right pod that has the right log, that does the right thing to the CRD, that doesn't update, that like this Rube Goldberg machine of complexity is different than a Terraform file, right? Like I can go look through the Terraform state file and say, I know where this went because everything was self-contained in this. The monolithic nature of Terraform was a good thing for debugging. Cluster API was built for cluster builders. It was made for companies that wanted to give you a same interface for a lot of different resources. And so all of these cloud providers become a cluster operator target, not cluster operator, CAPI, cluster API. It's like you run a controller for AWS and it can create all your AWS resources. And then if I want on-prem, if I want VMware, if I want something else, like all these things are more controllers that become Kubernetes clusters or Kubernetes controllers. And then when I have to upgrade that central management Kubernetes cluster, it is like the most risky thing you can do. And it is this huge cluster that's like, well, you know what? Maybe Terraform looked good, right? Like maybe actually going back to it, like I don't want everything to be a Kubernetes problem. And when you have to upgrade it, like literally for EKS Anywhere, like you would download all the etcd data to your laptop. And so like, okay, well now like my laptop is like critical to the production environment running. And I have to upgrade the Kubernetes cluster. I have to put all that stuff back into a database where I'm like, that is a bad idea. I don't care who you are. I don't care if this is Kubernetes or not. Like you do not want to like, let me download the SQL database to my laptop, do some stuff to it and then restore it back. Like that's just not like we've learned that over time, but that's where almost all of them kind of collapsed. And this cluster API made everything a Kubernetes problem because we loved the builders loved Kubernetes so much. They said everyone should have Kubernetes everywhere. And then it also segmented all those things and said, oh, this is the controller for AWS. This is the one for VMware. And so it made it easy to say, I want a VMware cluster. Cool. I want an AWS cluster. Cool. I want whatever bare metal. Great. But once you say, I want a VMware cluster with bare metal as the worker nodes in AWS for bursting, you can't do that. Like all this isolation became really hard. And so all of the providers today that are based on cluster API, they still have this mindset of you're running it in one place. Your Kubernetes cluster only goes in VMware. It only goes on bare metal. And you can't span that. And then you can't talk across data centers because we maintain it and we manage it. The way it's built is for this sort of notion of like the DigitalOcean controller is managed by DigitalOcean. And they're the ones that build it. And they're never going to have a DigitalOcean controller that also spans on-prem. That's just not going to happen. for us, Sidero, we are agnostic to all of that. And we had a product that was built on Cluster API and we didn't like it. It was too complex. It was hard to operate. It had all these limitations. And especially with things like bare metal, where Cluster API assumes when you are updating your nodes, you can get a new one. You can call an API and roll the cluster by creating new ones and then deleting old ones. And that was the notion of but bare metal's not that way. Bare metal is static. I bought that, I racked it, I named it. It has a static IP address. I'm not rolling that somewhere. And so we needed a different way to operate and say, actually, Talos is the operating system, has an API. We can call that API. We can upgrade that machine in place. And in place upgrades is something, again, that Cluster API is not interested in. They're not interested in saying you can span multiple data centers or multiple providers because the way it's built and the way it's kind of combined together. And so we built a thing that was based on that. That was kind of the landscape at the time. Everyone does that now. That's just where everyone's at. And as far as I know, we're the only ones that have something that's not Cluster API based today for on-prem usage that says actually, this is your infrastructure and Kubernetes is the layer on top of infrastructure. However you get a machine into this area of management, we can consume it and we can connect it because we have WireGuard VPNs and all that stuff. And so it was a different way of thinking because we're you can do Cluster API things with Talos and Omni and stuff, but it's not that's not what we're building. That's not actually how we're kind of maintaining it. We think there's too many limitations for people that want to be on-prem.
Yeah. So if you look forward, 5 years out, what's next, right, for Kubernetes on-prem? You mentioned the fact that if you have stuff running, just don't make everything a Kubernetes problem. Don't think, you have a hammer, not everything is a nail kind of thing. But, it also brings some complexity, right? Because then you have some stuff that's running outside and then you have your Kubernetes. So the amount of stuff you need to know, maybe it's different environments. I'm more thinking the sort of complexity. Where do you see we're going with this?
There's always going to be the back and forth of people that I don't want to have to know this or I need to know this. People that have a reaction to the cloud being too expensive and say, I'm going to run it all on-prem. The people that went all in on Kubernetes and Cluster API and this is too complex. I don't want this. I'm going back to Terraform. That pendulum's always going to swing. And I'm hoping some people are settling into the understanding what it is that they need to know. Just like my car analogy, right? I got a flat tire last week. I was driving on the freeway in the rain, saw the pressure go down and the pressure warning came up and I'm I know where to look for this. I can change the dial. I can see all the pressure on my tires and I'm okay, all of them are correct, but this one's a little low. I was I don't know if that's just because it's low or I actually just ran over something. And so I just watched it. Got my kids in the car. We're going somewhere. It's pouring rain. And I just watched the pressure go down slowly. It's just 5 PSI. I'm oh man, it's a flat. Can I make it to my destination without this failing on me? Let me just ride another mile and see what this rate of change is before I might have to do something. Determined, no, I'm not going to make it where I need to go before I'm right on the rim. And I know I don't want to do that. So just calmly, I gave my phone to my son. I said, hey, text your mom, let her know. This is where we're at. Text the people we're meeting, let them know we're going to be a little bit late. I'm pulling off the freeway here. Still, they didn't even, what are you doing? I'm don't worry, we have a flat tire. I know how to change a flat tire, thankfully, right? I have that skill set. It is a thing that I don't do often, but I know how to do it. And that was good enough for me to make it to my destination on time because I had the skill set. I had built that up over time to be able to just know, is this an important thing for me to know? Or is this something that I should just call a tow truck for, right? I have both options. And the tow truck would have taken me a lot longer in the rain waiting for someone else to do the work. And by skilling myself up and just saying, okay, I need this and I want a spare tire to be available on my car at all times. That makes me have worse gas mileage and I almost never think about, right? Until I need it. Technology and operating things is the same situation, which is hey, I want that skill set in my bag somewhere. So I know I can do this if I need to. I don't need it all the time. Hopefully if everything goes well, I need it never, right? Like I never have to use a spare tire. But if we're in the situation where something's broken or we have to change quickly or we need to get to a destination with software, we should have enough of the skills to be able to get us there on time. And Kubernetes on-prem is one of those tools. It can be because it gives you that API layer that a lot of people are building themselves. Almost every on-prem enterprise, they all have platform teams now, and they all think that they're building something that they actually need in a way that is going to be sustainable long-term. I've been around long enough that every single one of those platforms ends up migrating from platform to platform. And the problem usually comes from like misalignment of incentives, where the team that is paying for platform engineering is the security team. Because they're like, I just need to be able to see all the vulnerabilities. And like, but you're serving the developers who don't care about that at all. And so they're building in all this stuff for the security team who's paying their bills when their customers are saying, I just want you to deploy this faster. Right. And like, I don't care what the security thing is. And like this misaligned incentives becomes a problem. And I don't think that that's going to go away because that's been around for a very long time. But being able just to start from a more common interface and say, this is Kubernetes. This is how this is going to work for us. This is how we're going to use it. Hopefully they look back at that and say, this is how much of it we actually want to use. Maybe we disable all of the beta APIs because we don't want people to accidentally do those things and then have us migrate off and have an outage or whatever. I'm hoping on-prem makes people a little more responsible and not just look at new and shiny. I don't have a lot of hopes for that looking back over the couple of decades that I've seen people doing it. Same thing with config management and all of these things in the past. They're, VM, golden images, all of these things were the tool to end all problems. And they never ended up being that way, but we found solutions where they made sense. And I hope that in 5 years' time, Kubernetes is in a spot where it makes more sense how people are using it. And it's not the hammer for all nails. It is the responsible area where they say, I need this much of Kubernetes. I love the APIs. I want it to manage these things. But maybe I keep my databases somewhere else. Maybe I keep my storage, my NFS isn't in Kubernetes, right? Like those sorts of things. Like, let's just figure out how to be responsible with it.
Yeah. Or, if we listen to what, I think it was Satya Nadella, who talked about, we're going in a world where it's all going to be AI and, SaaS service is just a CRUD. It's just a database with CRUD.
Yeah. And most applications are that, right? Like most of them are data over here, change data a little bit, send data over there, right? Like that's not like, if we dumb it down, like that's the essence of most software. But also like it's a lot more complex than that too, because people are in the mix and people and environments and process is a lot more complicated than that.
Yeah. All right. Excellent. Well, time to wrap up. We have spoken about how the cloud is changing, perhaps how it's becoming more of an operating model, right? And perhaps on-prem should not be, I used to think personally, on-prem is the same as private cloud, but maybe I will, maybe I have to reconsider now, based on what we've discussed, right? So we've also spoken about Kubernetes on-prem, right? As opposed to using services like GKE or EKS, and how you can do self-managed in SaaS. Well, thank you, Justin. And that's it for today. Thank you all for listening.